Alright, so the first question we're going to look at is if 25 milliliters of water are added to 125 milliliters of a 0.15 molar sodium hydroxide solution, what would be the molarity of the diluted solution? So what I like to do is kind of set up the M1, V1, M2, V2. So our starting solution is 125 milliliters of a 0.15 molar solution. So 0.15 molar is our starter. And then 125 milliliters is the volume. Then we have 25 milliliters of water added to the 125. So our final volume is going to be 150 milliliters. And then there's no reference to this M2, so we put a question mark there. So then remember our equation, M1 V1 equals M2 V2. We're going to set that up. So 0.15 molar times 125 milliliters equals M2, which we don't know, times 150 milliliters. So 1.15 times 125 milliliters equals 18.75. and that is equivalent to the M2 times 150. So we're going to divide by 150. And we end up with M2 equals 0.125 molar. All right, our next question. If water is added to a 100 milliliter 3.25 molar hydrochloric acid solution until the final volume is 150 milliliters, what will be the molarity of the diluted solution? So we've got, again, M1, V1, M2, V2. So we have our initial, because this is what is being added to. So 3.25 molar, 100 milliliters, and then the final volume is 150 milliliters. So we don't know M2. Setup's going to be the same, 3.25 molar times 100 milliliters equals M2 times 150. So we are going to multiply these two together, so we should get 325 molar. It's going to be 325 molar times milliliter, which is kind of weird. And then 150 M2 still, liters times M2. We're going to divide by that 150 on each side. And we end up with, let's clear this up, 325 divided by 150 equals 2.16 repeating for our molarity, otherwise known as M2. Our next question, how much 0.05 molar sodium chloride solution is made by diluting 250 milliliters of a 10 molar solution? So we've got M1, V1. So our initial, so we've got 10 molar, 250 mils. And then M2, we want it to be 0.05. V2, we don't know. So 10 molar times 250 milliliters equals 0.05 molar times V2, because we don't know what it is. So 10 times 250 is 2500, and that is equivalent to 0.05 times V squared, right? So we're going to divide by 0.05 on each side. And we end up with 50,000. Remember, this is milliliters for V2. Next question. 345 milliliters of a 1.5 molar potassium iodide solution is boiled until the volume is 250 milliliters. What is the molarity of the new solution? So we have some reduction here. So we've got 1.5 molar initially with 345 milliliters. And then our final volume is 250 milliliters, but we don't know M2. So 1.5 times 345 equals M2, which we don't know, times 250. So 1.5 times 345 equals 5175, and that's M2 times 250, so we're going to divide by 250 on each side. So our answer is 2.07 equals M2. So how much water would be added to 500 milliliters of a 2.4 molar potassium chloride solution to make it 1 molar? So we've got M1, V1. So our initial is 500 milliliters for volume, 2.4 molar, and our secondary molarity should be 1 molar, and our volume 2 is going to be some number, which we're going to have to figure out then how much is added. So we got 2.4 times 500 equals 1 times V2. So when we solve for that, we do 2.4 times 500, it's 1200, and that's equivalent to 1 times V2, which if we divide by 1 then, we get V2 equals 1200 milliliters. Now here's the tricky part. 1200 milliliters is our final volume, which means we added something to 500 to get 1200. So 1200 equals that added volume plus 500. So the added volume is equal to 700 milliliters. So I just subtract the 500 from each side, and I get that 700 milliliters. So for the rest of these, you're going through your types of practice homework. I will do one of each color. So we've got, what is the molarity? So remember, molarity equals moles per liter. And we have molarity equals 0.39 moles here, and 5 liters. So divided by 5 liters. Just a second. Molar. And then next we have, I became a video key, sorry. We have how many moles are required to make 50 liters of a 0.52 molar solution. So we have 0.52 molar is equivalent to something over 50 liters. And if you have your card, you might remember that moles are equal to the molarity times the liters. So we could rearrange this to say 0.52 times 50 equals 26 moles. All right, number 12. How many liters are required to make a 0.52 molar solution with 4.5 moles? So normally 0.52 equals 4.5 moles over some liters. But we could rearrange to say that liters equals moles over molarity. So we could say liters equals 4.5 over 0.52, which is equivalent to 8.65 liters. All right. So we could do 15. So we have 348 grams of potassium iodide, which means we need to go to moles. So we're going to find the molar mass of potassium iodide. Potassium is 39.1, and iodide down here in the corner is 126.9. So we get 166. So to go from mass to moles, we're going to divide by the molar mass. So 348 divided by 166 equals 2.09 moles. And then remember, molarity equals moles per liter. So 2.09 divided by 4.3 is going to equal our molarity. So take that number from your calculator, divide it by 4.3, and we get 0.487 or 0.49 molar. All right, good luck studying.